Hi everyone, I'm Damien Larocque. I'm here with Greg Rell and Winifred Camille, and this is our demo presentation on blockchain and digital signing. So today we're going to give you an overview of the blockchain and digital signing technology as used in smart contracts. And then Greg is going to go over the execution of smart contracts in Python code. And then finally, Winifred will give us resources to learn more about blockchain technology, as well as future extensions of the technology. So first, I'm just going to briefly run through the blockchain architecture. And blockchain is essentially just a decentralized and distributed ledger that can hold any kind of data you want it to. In the case of Bitcoin, it stores exchanges of currency. And some of the key functions that come together to form the blockchain architecture is cryptographic hashing, digital signatures, and consensus algorithm. So cryptographic hashing is important because it allows every node on the network to run the data through the hash and ensure that no data has been changed. Because as you know, with hashing functions, any small data in the input is going to give you a completely different digest. So that way, all holders of the blockchain can verify that the data in there is unchanged. And then I'll show a little bit of digital signature on the next slide. And then finally, there's the consensus algorithm, which most commonly used in blockchain is going to be proof of work, where it's just a mechanism for validating the data in the blockchain before it is added to the blockchain. And the way it kind of works is that, as you can see in the graphic I have here, there's a header field on each block with a nonce, which is just a random number. And then you have these miners who compete to calculate the nonce plus the data in the blockchain that gives a hash that meets some criteria. In the case of Bitcoin, it's getting the nonce plus the data to give you, when run through the hash function, to give you a bunch of leading zeros. And then you adjust the leading zeros based on how many competitors are there so that you have an average mining time. Because if you can mine a block too quickly or too easily, then you could have one node pushing all the blocks to the blockchain, and they could essentially control what's shown on the blockchain. And with digital signatures, the way it works is that every node has a public and private key. So in this graphic here that's showing a quick demo is Alice is hashing a data, and then she's using her private key to encrypt that data. Once it's sent to, let's say Bob is going to verify. Bob is on the blockchain. He wants to verify that data. In the verification phase, he's going to take that data that Alice pushed to the blockchain, decrypt it with her public key, and then compare that data to the data run through the hash function. If they match, then he can be confident that the only way that Alice would have been able to produce that is using her private key. So smart contracts are built upon on top of blockchain technology, and they have the clauses, the conditions, and they are automatically executed once those conditions are met. And the contract is going to store what is at stake in the contract, who's involved in the contract, and all the other types of data you'd want to have inside a contract. And one benefit to that is that it cuts down on administrative costs because you don't have to go through a third or central party to verify these contracts. It's more secure because if you have a central node that's verifying all these contracts, it's vulnerable to malware attacks and manipulation. So this graphic kind of shows what's involved. So let's say you have some lawyers, some people in a company, and software engineer. They prepare a contract. They're going to negotiate back and forth. Once parties involved in the contract agree on what should be in the contract, is deployed to the blockchain. And then in the execution phase, the blockchain keeps checking to see that those conditions are met. They be in the form of if-else statements. Once those conditions are met, it's automatically executed, and the assets involved in the blockchain is unfreezed. And finally, to show smart contracts in multi-agent systems, you can imagine it'd be very important for agents in a multi-agent system to have trust between each other. How do they know that other agents have completed their work, that the data they're sending is valid, that it's not tampered with by hacking or any cyber forces. So we're going to show what smart contracts look like in Python this demo. So with that, I'm going to hand over to Greg, who's going to take it.
Okay, the smart contract demonstration that I'm going to show to you today is by a company called Algorand, and this company deals specifically with smart contracts and smart contract ledgers. It's written in Python. I want to make sure you can see it. And the premise of it is that the demo is based on having an auction that lasts for 30 seconds. And the premise is that one agent will sell an NFT, a non-fungible token, by putting it up for sale on an auction under a smart contract. And under the contract, it basically states that the auction will last for 30 seconds, and the contract will be funded by incoming bids. The highest bidder at the end of the auction will receive the NFT. And as part of the contract code, if you have a bidder who is currently the highest bidder and somebody else bids, that money is then returned to the previous bidder, and the new bidder then has their funds go to the smart contract. And of course, at the end of the auction, the contract will then conclude, and the NFT will go to the winner, and the money will go to the seller. So in order to run the contract, in order to run the demo, you must have Docker set up. The blockchain is going to be contained within a Docker instance. So to get it up and running, simply clone the Git repo. Set up the Docker instance. And running the demonstration. The demo will generate 3 agents, each with their own IDs, their own hashes. Agent 1 is now generating an example NFT. Agent 2 is creating the auction that lasts 30 seconds to auction off that NFT. Agent 1 is now setting up and funding the NFT auction under the smart contract terms. Now, Agent 3 wants to bid on this NFT, showing the balance, placing a bid for 100,000 microalgos, which is the unit of currency in this demo. And now the demonstration is simply just going to wait until the expiration time as set up by the contract. In this period of time, any other agents could come in and bid a higher value, in which Agent 3 would have their original value returned to them. And time has expired. Now Agent 1 is closing out the auction, and the NFT went to Agent 3 and with the NFT ID, and Agent 1 received the funding from Agent 3. The smart contract itself is written in Python. However, it's written under a library called PyTeal, which by itself is its own version of a programming language, which is developed by this Algorand company. The real important details of the contract itself, the stipulations within the contract, can be found within the logic. And based on the fact that everything's on the ledger and every action is contained within the ledger, it is immutable, and therefore a way to automatically buy and sell things using using multi-agent systems. So I'm going to now turn it over to the last presenter, and thank you.
All right, can you guys see my screen?
Yep. We can.
All right, so now I want to talk about a few links where you can go ahead and learn more about blockchain. All right, so the first one would be the Algorand website. So this is what we use for our demonstration. And if you guys want to go ahead and run the demo for yourself, you can just go to the page it gives you step-by-step instructions how to set up the environment and so that you can run the demo. And of course, once you go through with it, you can modify it and then you can play with it. It's pretty interesting. The next link that I want to talk about is I want to show you guys is this paper from IEEE. It talks about trust management for MES systems, and particular with blockchain and the different challenges um, that ought to be overcome. And also, this one is about blockchain challenges and opportunities. And it same thing, it talks about blockchains. So we went through all those different papers so that we can prepare our presentations, and those are pretty interesting reads. And the last one that we also went through was this one that talks about the challenges and advances in platforms. And one second, please. Now I want to go ahead and talk about a few blockchain's technology and future extension. Let me get I'm sorry. Uh, there you go. So future extensions that I want to talk about with blockchains. I want to talk about notary, cars, COVID-19, and voting. So all right, so notary. So, of course, as we know, a notary is a person authorized to verify the signature of parties in all kind of documents. So, with blockchain, the notarization of a document would automatically be recorded, record the date, the time, and location. And also, of course, because the process is automated, it would save quite a bit of time, and also be saving money because fees would be extremely low. So I found this article that talks about the different type of service and benefits that we can expect from a notary using blockchain technology. All right, and now one of the things people pay attention to when purchasing a car is the mileage. So some people have been known to tamper with the mileage of cars to make people think that the car is newer than it actually is. So with blockchain and a digital odometer connected to the internet, the car mileage would be recorded periodically. And since that data cannot be changed, we can be sure that the mileage history of the car would be accurate. This company, Bosch IoT Lab, has been working on blockchain technology to prevent odometer fraud. You can learn more about them and their work from this blog page. All right. So when COVID-19 hit, it was several steps ahead of us for a long time. And one of the reasons was the lack of speed when it came to gathering data about the outbreak. Also, one of the most effective ways to contain an outbreak is to track the people who comes in contact with the infected. So this paper explores several blockchain applications, from reviewing data to developing tracking system to aid in the combat against COVID-19. And of course, should there be any future outbreaks. And the last paper that I want to, well, actually, this is an article, is regarding voting. So voting, of course, is a process that can be challenging to implement online because of its importance and the potentiality of being hacked online. So blockchain could be the answer. After a voter identified as identity has been authenticated, his vote and identity would be recorded. So again, the immutability of blocks ensure a person's vote is not changed after the fact. Also, because the ledger is distributed, anybody can look at the final count, resulting in a transparent system. So this article talks about how blockchain can prevent voter fraud. Such system would have to overcome several challenges, but definitely something to keep an eye on. All right, and that is it.